but you can see what I'm seeing is that in the lower right-hand corner, it seems like the points extend from there, but then in the upper left-hand corner, it seems like it's skewed just to the right a little bit. I wonder why that is.
No, I don't know.
I would think they would be symmetrical on both sides.
I wonder how it. How can we manage the?
Where was your first point?
Yeah, how can we manipulate it?
Yeah, how can we manipulate it with the vertices that you provided to the polygon?
It's either the upper. It might be the upper left or else the one over. Let's see. Because I might have stepped. Yeah. No, I don't.
Did you carry the one? Is that what happened? You carried the one.
Looks like
You could write a custom shader that draws points at the points of the vertices, so we could see what's really going on.
Not now.
Not right now. Come on.
So
the reader.
What we've learned today, though, is that wireframe is a really cool way to visualize what's going on with the shaders here.
Yeah.
Yeah, it gives you a clue as you might have made a mistake. Not so much a mistake, but you didn't do what you thought you were doing. Perhaps.
Yeah. I mean, when people draw pictures, artists draw pictures, they flip the picture back and forth, just so that they can see it differently and know that they're getting the effect that they want, and they're constantly doing that, drawing a little bit, flipping it back and forth, and making sure the balance is there and all that stuff like that. And yeah, why not visualize what you're actually trying to do to make sure you're getting what you want?
Yeah.
Okay, well that's a nice little nugget. Okay, so did you say you had some other examples? I mean, we want
to. Yes, I'm going to show noise first.
I think we're through beating you with that example. Can we do another one?
Okay. So this, let's see here. This is a kind of a cutaway, or not a cutaway, a cutout. Where I draw a line over something and I use it to stencil out those pixels. It's another mask. I've got all kinds of masks now. And this is using noise. So it would normally be something like this. But since I've applied noise to it, I've varied the height up a bit. And
so I'm assuming frequency is applying some sort of waveform, whatever, to the.
You can go back and forth between these.
That's cool.
And that.
So right now it's doing just a black. Is that what it's supposed to do? Just a black.
Black or with a background image. Yeah.
Oh, I see. Okay, I gotcha. Now you can. Gotcha. So what? Okay, that's cool.
That's an example of noise.
Right.
It's not a Vertex shader thing. It's just.
What just on the fly here? Is anybody in the panel? I mean, could you see a practical application for something like that? Like what would you do? Like this one would be a cool microscope sort of thing, right? Like a.
Yeah, these are other types of noise.
Like there'd be all kinds of applications for something like this in games specifically.
Yeah, it seems like there's a technical aspects of it, and then there's the creative aspects of it, right? Coming up with a story.
Just, figuring out how it fits into your story, and then taking advantage of this. Because with this, you very quickly, not very quickly. The development times may be a little bit longer, but the demand on your processing time is going to be very low, and not put a lot of demand on the mobile device that you're deploying this to. Which that's the huge advantage of all of the shaders.
Well, Stephen, go back to the one, the spheres there, where you had the it looked like the sun. Sorry, I know you just killed your screen share.
Sure.
So there's spheres, and then that one. It looks like the sun, right? So, I mean, let's say you are doing a cutscene or something that involves. Flying to the sun, or flying into the sun, or you're going to launch yourself around the sun, or whatever that storyline is.
You've got a game with magic in it. Here's a great fireball.
I've been thinking of using it as a fireball. This is called fractional Brownian motion.
You mix that with some particle effects behind it to add just like a halo effect to it or something. It's awesome.
Yes. And the demand on the phone is going to be very small, and you're going to get a much more realistic or live impact from that special effect, rather than just using a static PNG file to shoot across there.
Well, and because I'm assuming that the variable element in these, you're using time probably to create some of the movement in these. Is that correct, Stephen?
And I think all of them, or almost all of them. Some of them I might be updating outside.
But if you were to do something a little more dynamic, so let's say that sphere was a physics body, and rather than time, you're using its linear velocity to impact that. So the faster it's going, the faster the motion happens on it. When it's not moving. I think there could be lots of cool things you could do with that.
Right, and you can feed all of these in through the Vertex user data. You have 4 of them, and so you can run out pretty quickly. You do have to be a bit judicious about how you allocate them. I have mentioned that if you can manage it, you can also use a texture as input, just of numbers, and then you have as many as you need. But it may be difficult to put your information in a form that you can read out of a texture.
Also, just thinking about practical applications for these sorts of things, I thought the RIP demo that you had there was awful cool. I mean, I just downloaded over the weekend Forever Lost 3, which is a Corona-made very successful game series, and it's sort of a 2D point-and-click adventure. And that's the kind of thing that I think in the first scene in that game, there's something with like a wallpaper that comes off. And this is not knocking them at all. Their presentation is beautiful in that, but you tap it and the thing comes off. But this is an opportunity to take something that is ultimately 2D and give more of a sense of if you're ripping it. So as you're dragging your finger, some of that, it reveals what's underneath it. I think there's lots of cool applications that these are relatively simple things that once I say that having not really mastered them, but I think once you have, they're a great way for low amount of work, big amount of impact in terms of visual presentation.
Well, yeah. I mean, everything that Stephen showed so far has been. It may be conceptually intensive and math, intensive, but the code. The block of code, it usually isn't that long, so it's almost like snippets. So yeah, if you can have a snippet that's part of your toolbox, then your ability to step up the game, so to speak, of your game seems to be the potential is there. I mean, you can really step it up.
It all seems like every 8 months to a year in the forums, there's somebody who wants to create a lottery scratch-off ticket, lottery scratch-off ticket effect. And I'm looking at this is a way to get some by using noise, by having it randomized. It creates this very realistic. It's like you said. It's if it's too straight, if it's too linear, it doesn't look real.
Right.
And this is a way to sort of achieve that without having to manually somehow create the effect. It's like no, just randomize it, right?
Steven, have you tried all of these shaders on a device?
I think so. Everything that's in this project that I'm looking at right now, I have fairly recently. There were some that would. It's been maybe a few weeks since I've tried them, so there might have been some things that have broken since then. But on my cheap Android, some of the noise do break down. Although I've been looking at some others that don't get such large numbers, so you might have to hunt around for some of these things. But
let me ask you, since you kind of mentioned that, do you find yourself having a least common denominator device? Is there a device that you go